Hi, this is Chelsea Queen from Women's Talk of the Heart. Per usual, I'll start with this segment off with a little bit of background information about the heart before we can get into our interviews for the day. The heart is a wonderful 14 centimeter long, 9 centimeter wide organ that lies in the mediastinum and rests on the diaphragm. This powerful organ has walls made of three layers: the epicardium, myocardium, and endocardium. Inside the layers, within the heart, there are four main chambers: two atria and two ventricles. Our heart gets the blood supply from coronary arteries that supply blood to the myocardium, and at the end, the blood is returned to the right atrium through cardiac veins in the coronary sinus. To maintain a healthy cardiac cycle, which is the atria contracting while the ventricles are relaxing, and vice versa. To keep up a physical exercise, body temperature, and concentration of various ions. It is now time to introduce our first topic. A problem arising with the complicated matter of the heart is heart surgery, performance, as well as the difficulty of finding a donor. Even more surprising is the alarming rate at which donor organs fail. To help patients at this vital end stage, bioventricular failure is the Syncardia Total Artificial Heart. Here today, telling us about this relatively new life-saving machine, is Dr. Hannah Smith, Syncardia expert and heart surgeon. So tell us, doctor, what really is Syncardia?
Syncardia is the only total artificial heart. And by totally artificial, I mean there's no heart in your body with this outstanding machine.
So a patient can live a normal life with this new man-made heart inside of them?
Yes, their life is very close to normal. Once a donor organ fails, the system only bridges the gap between the new donor organ transplant. The heart is attached to a 13.5-pound backpack battery that powers the heart. Usually the patient stays with the artificial heart in the hospital for 2 months, then they are able to live on their own for up to 2 years without a real heart.
And have you really seen this work?
Yes, one of my patients, Michelle Johnson, was able to live with her family for months on the artificial heart. Our hospital, as well as 24 others in the nation, use the Syncardia system. It's really amazing. It pumps 9.5 liters of blood through the body through two ventricles, similarly designed to the human heart, and over 1,000 patients have relied on it, and it's given a total of 270 years of life to the people of our nation.
That's outstanding. Now, Dr. Smith, you're also very educated in the health of women and their heart. There's a new study going on about the increasing risk of heart disease in women. Is this correct?
That is correct. It's commonly thought of as a disease mainly for men. However, it is becoming very common in the young female. The reason for this is there are many risk factors that women may have that they aren't aware of that are linked to the heart.
Can you elaborate on a few risk factors that can help cause heart disease?
For starters, oh, absolutely. For starters, a common yet unthought of risk is breast and ovarian cancer. The genes for these are also related to heart disease risks. The reason is these genes are mutated that the genes are mutated that can alter your recovery from a heart attack. Because of this, the heart attacks in women can be twice as severe and 3 to 5 times more fatal. Another big risk is excessive calcium in the body. The new research suggests that 31% of women who take 1,000 milligrams a day are more likely to get heart disease. Another surprising risk factor is chemotherapy. Although it does not save your life, it increases your chance of developing heart disease. 32% of women who have undergone chemo have reported getting heart disease within 10 years. The reasoning is the drug anthracycline that women are given that weakens the heart and increasing heart disease like cholesterol and blood pressure.
That is a lot of random ideas for causing heart disease in women. What other kinds are there, briefly?
Risks can include HPV, human papillomavirus, age-related stiff arteries, insufficient screening of the heart, radiation therapy, metabolic syndrome, and of course, just being a plain couch potato.
Well, that is definitely good to know. Dr. Smith, thank you so much for joining us today on Women's Talk of the Heart. Next, we have some interesting insight on Dr. Nicole Ugolini's work. Go ahead and say hello.
Hello, everyone. It's nice to be here.
It's great to have you. So tell me, what is it exactly that you have discovered during your newest research, Doctor?
My team and I have been able to gain enough information to map out a blueprint of sorts of the heart. We were able to do so by recording precise orders and timings of literally hundreds of genetic switches from the embryonic stem cell stage to a fully functioning heart.
That sounds very complex. I would love to hear more details on this. What could these findings do for our current medical field as of today?
You see, this research could help further the understanding of heart defects that occur every year worldwide. As it is now, the U.S. has more than 35,000 newborns whom are affected by heart diseases and defects yearly. The most common of these being arrhythmia, which is irregular heartbeats, and ventricular septal defect, which are holes in the heart.
I see. Now tell me, how did you go about this process? How was it that you and your team even began to map out this so-called blueprint?
Well, to begin this entire process, my team took embryonic stem cells from mice and put them into cultures that would replicate embryonic development. Then we reprogrammed the cells to form those of a beating heart, and after that, DNA was extracted from the developing and mature heart cells. This is because they contain important epigenetic signatures.
Would you please tell us what that means?
Epigenetic signatures are what we call the process in which genes switch on and off during development. This turning on and off of genes controls how the body works. A good example would be like the neurons in our brains.
That's amazing. So what did you do next after that?
Well, with the help of some very high-tech computers, we were able to turn all of our recorded data into an organized and readable blueprint. And that was basically it. My team is full of very amazing people, and I would never be able to do it without all of them.
Incredible. So, to sum it all up, you obtained a whole new look on how the heart works, discovered that the heart cells switch on and off along with their genes, and potentially opened up a new realm of medical heart treatments.
That's correct.
Well, I would just like to thank you for coming on the show today. It looks like our time is up for now, but please come back and visit us sometime soon. For now, thanks for listening to Women's Talk of the Heart, and don't forget to tune in next time.